Welcome back everyone to this continued lecture on group by operations, specifically on working with that multi-level index that's created after you group by two or more columns. So let's head back to the notebook where we left off last time. Alright, so here I am in the notebook right where we left off last time. As you can recall previously that we saw if I say group by and then I use two or more columns and then perform some sort of aggregate operation, what happens is if we go ahead and run this and I check out year cylinder, I have this multi-level index. I have the model year level on the outside and then the cylinders level on the inside. So again, this index is labeled model year, outer level, cylinders, inner level. And technically you can have more than just two levels. And you can see .index.levels reports back the options for each level. And then we saw that the multi-index actually gives you these tuple pairings, or there's more than two items if you have more than two levels. But essentially, we can see we have 4 cylinders for 1970 row, 6 cylinders for 1970 row, and so on. And if you want to grab just one of these rows, like 1982 6 cylinders, and just grab this highlighted row there, then what you do is you just say .loc, and as a tuple, you can provide that tuple pairing. Okay, but now let's go ahead and move on and talk about using something called a cross-section, which is a more general purpose way of grabbing something that has this multi-level index. And the method call is .xs. So what I'm going to do is quickly take a look at year cylinder. I can see right here I have model year and cylinders, and then I'm going to call .xs, which is, if we take a look at here, it's a cross-section. So essentially what this does is it takes in a key. An optional axis, by default, we'll keep it at 0, since that just means look at the rows, and we want to have our multi-index levels on the rows. And then we can also see that we have this level option. And the level just refers to what actual index you're looking at. So are we looking at the model year level or the cylinders level? So let's imagine I wanted to grab just model year for 1970. The way this works is we provide the key. In this case, the key is actually just the integer 70. And then I have to tell it what level I'm looking at. So I'll say I'm looking at the level model underscore year. And if I run this, I get back that subsection here for that particular key at this particular level. Something to keep in mind is when you're using cross-section, it only takes in a single key as the value. So if you wanted to try something like 70, 80, this actually wouldn't work. So if you run that, it's going to say key error. I can't find 70, 80 as a key. So you can't actually pass in a list to get multi-levels. Instead, if you were dealing with this data frame, and for some reason you wanted the year 1970 and the year 1980, as we showed you in the previous lecture, you just call .loc and then pass in that list of options. You'll say, okay, give me 70 and give me 80 as a list, run that, and it works automatically here on the outside index. So if I have the capability to already use .loc, what's the use of cross-section? Well, what I don't know how to do so far is grab something based off this inside index. For example, let's imagine I wanted to grab only the 4-cylinder cars, but I wanted to do it for every single year. I can't really do that easily with .loc. Instead, that's where we're going to use this cross-section tool. So what I'll do here, let me just run year cylinder so we can see it. Again, what I'm looking for are the instances of 4 cylinders for every single year. So I want this first row here, then I want this next row, then this middle row here, etc. So I say cross-section, XS, and the key I'm looking for is 4 cylinders. However, I just need to let cross-section know that the level I'm looking at is this cylinders level. So I copy and paste that here. And then when we run this, I get back this nice data frame that shows me the model year and then the values. Something to keep in mind is that when you're asking for a particular level, like cylinders, or up here we're asking for the level model year, that actual level then is not shown in the results because there is only one attribute or one value for that level. So what I mean by that is the reason we're not seeing model year here is because they're all the same. It's all 1970 or 70. And the reason we're not seeing cylinders in this output is because it's all the same. It's 4 cylinders. So just keep that in mind. If I just look at this data frame on its own without knowing the code that produced it, I actually have no way of telling what cylinders this is referring to. So when I actually assign this to some sort of variable, I would probably want to say something like for cylinder is equal to, etc. Because the key itself is not super apparent what I chose in the actual output. So just a little tip to keep in mind as you're working with this. And then another thing I want to note is people then ask, rightly so, if I'm looking at year cylinder, and let's say I actually want the cylinders for 6 and 8 for every single year. Well, that leaves us in a bit of a conundrum because I just told you we can only put one value as the key. And if you're trying to then select certain cylinders, then it's probably much easier to filter out those values before you run the group by call. So you should always keep in mind that what actual values are you looking for in the final results. And if since the beginning you were only interested in the cylinders for 6 and 8, then you should filter that out in the original data frame first and then just call your group by. That's going to be a lot easier to both do and read than trying to mess around with .loc and .cross-section to get those results. So, for example, if you only want the aggregate for cylinders 6 and 8 for every year, what you should do is just before you even call group by, say, okay, give me data frame, where data frame of cylinders is in, and then you pass in the options you're looking for, like 6 and 8. And so now we see here our data frame where we only have 6 and 8 cylinder cars. Once you've done that filter, then go ahead and call group by cylinders or model year or whatever you're looking for. So in this case, we can go ahead and just do both, model year and then cylinders, and then grab the mean that way. So this gives you that result of only 6 and 8 cylinders for that particular model year. So a lot of times I see beginning students get confused. They're trying to figure out how to do something like this using .loc or .cross-section when it's actually just a lot easier to filter out your data frame first and then call group by on what you want. So always try to keep that in mind as far as what's the simplest way to get the final results you're looking for. And often you'll find it's a lot easier to do the filtering and conditional filtering on the data frame first and then do your aggregate functions. Okay. So finally, what I want to show you are things like swapping the levels and sorting the multi-level index. So for example, we come over here. I still have this year cylinder object. And currently, the outer level is model year, inner level is cylinders. Technically, I think that makes the most sense. But if for some reason you wanted to swap these, make cylinders the outer level and model year the inner level, all you need to do is say swap level, open close parentheses, and it will swap it for you. So we can see here now cylinders is on the outside and model year is on the inside. Whether or not that's useful kind of depends on the situation, but it is available for you to swap the levels. Okay, and then finally, let's go ahead and show you how to sort the multi-level index. So right now it's sorted model year from earliest model year to the latest model year, but what if you wanted it in descending order, starting from the most recent to the bottom? Then actually all you need to do is, just as before, say sort index, and then you can specify which index you actually want to sort by. So for example, I can say the index I want to sort by, the level is model year level, and I actually want it with ascending is equal to false. So it's the same command or same method that we saw earlier, except now we actually just provide the level parameter that we're dealing with. So you run that, and you can see now we have it in descending order. Something to keep in mind, if you start looking at inside levels and start sorting by that, then you may start breaking up this grouping. For example, if we say cylinders, ascending is false, you'll notice suddenly it breaks that relationship because you have 8 cylinders for multiple years. So just keep that in mind. Usually when you're sorting, it makes sense to sort by the most outer level. Last thing I'm going to show you in this particular method is a more advanced method that allows you to customize what aggregate functions you want per category. It's a pretty neat advanced feature. We won't really see it too often, but hopefully in your own work, you may find it helpful sometimes. So let's jump back and take a look at our original data frame. And as I mentioned before, when we're thinking about doing group by, we've just been applying the same aggregate function to every single column here. So we did the mean of MPG, mean of cylinders, displacement, horsepower, weight, etc., depending on what you actually choose to group by. But sometimes it doesn't actually make sense to do the same aggregate function on every single column. So what I want to show you is how you can actually specify a particular aggregate function or group of aggregate functions for a particular column. And the way you do that is through the .agg, which is the generalized aggregation method. So we'll say df.agg, and this is then going to aggregate, and it can actually take in a list of string calls. And the string calls are going to match up with the method name in the table in the lecture notebook. So recall in that lecture notebook, let me just bring it in here real quick. At the very top of it, I mentioned, if you scroll all the way to the top, that there are some common options here. There's also a link to the online documentation. But you'll notice we have mean, sum, size, count, etc. So the string calls you're about to see me type in, they come from this list of common options. But what I really want to show you here is with the aggregate method, you can essentially say, okay, give me the mean of the MPG column, but the standard deviation of another column. So to show you how this is run, let's first do it on all the columns, and then we'll show you how to pass in the dictionary. So on all the columns, if I wanted mean and standard deviation, here inside of this add call, let me zoom in one level here. Inside of this add call, I say, give me the standard deviation and the mean. And then I run that, I see aggregation, standard deviation, and mean. And here it is as the index, standard deviation, mean for all the columns. Now you'll notice that some of these don't really make sense. Standard deviation of the model year or the origin doesn't really make sense either. So some people then would take this and just filter out by what they're actually looking for, like MPG, for instance. But let's imagine that you only wanted some aggregate functions for some particular columns. Well, the way we can do this is we actually pass in a dictionary into the aggregation call. And this is this advanced method that's really useful as you start to upgrade your skills with Pandas. And what you do here is you pass in a dictionary where the key is the column you're interested in, and then the values are a list of the methods you want to call. For example, let's imagine I wanted to call max and comma mean for the MPG column. And then as another key value pair in this dictionary, I'll go ahead and grab weight and then say, well, I'm only interested in the mean of the weights as well as the standard deviation of the weight. So note what I'm doing here. I'm actually applying specific aggregation functions to a specific column, and they actually don't need to match up with the other aggregation functions I'm passing in for another column. And when you run this, you get back this nice result where you see your columns, the original ones, MPG and weight, and you can see the max and mean for the values you're interested in, and for example, the mean and standard deviation for the weight column. Now, keep in mind, it's going to fill in a nan value for things you didn't call. Since I didn't call standard deviation on MPG, it just fills it in as a null value. And this will often make sense depending on your particular data set. Because for whatever reason, maybe it didn't make sense to grab the max for the weight here, etc. So this is just the kind of most advanced method you can use to apply particular aggregation methods to particular columns. Okay, there's a lot more examples in the lecture notebook. We really won't actually execute something like this on our own in our projects later on in the course, but I do want you to be aware of it because it's a super powerful tool, especially when you're writing things like reports for other people, and you don't want them to start thinking, oh, why did they report some aggregate function for a column where it doesn't make sense? So this allows you to just replace it with null values if for some reason it doesn't make sense for that particular column. Okay, thanks, and I'll see you at the next lecture.